Hi. Today we will see how to produce an animation synchronized with the sound. To do this, we need to analyze the sound and create keyframes according to the bits of the specific sound, which we would like to use. With the help of these keyframes, we will create latent keyframes, a principle very similar to what we saw in the previous video, and for those who missed it, I will leave a link in the description of the video. As usual, we will start at the beginning. There is a very similar workflow here to what we saw in the previous video. AnimateDiff is adapted to LCM. I used the Dream Shaper model. In the positive prompt I wrote, photo of a flickering, neon, 1.2 sign, on small store in an alley, high quality, sharp. Empty latent, we will start with 16 frames. NK sampler is quite basic, adapted to LCM, and let's see what came out. We definitely have a neon sign. Now we will connect our text to the animation. For this we will use ControlNet. I choose Advanced-ControlNet, and for the model I use Canny. We also need a reference image, and I will use the name of the channel Pixel Easel, as an example. Of course, you need to prepare the image for ControlNet, select the AIO preprocessor, connect all the spaghetti, and press Q. And this is the result we got. As you can see, you can definitely read the text, but we lost the sign and the neon. So I'll try to lower the strength, and maybe, also the end preset, and I'll save on Q again. Now you can already see a combination of the text inside a sign with neon lighting. It is still difficult to read the text, and this is exactly what we will try to do with the keyframes, to give the feeling that every time there is the strong sound of the electric current, the letters on the sign will light up. In order for the keyframes to be exactly on the beat, we need to use a tool that knows how to analyze the sound and create keyframes exactly on the beat. You can use all kinds of tools, but my favorite tool is Parseq. I've been using it since the days when we only had Automatic 1111, and we didn't even dream of Comfy. There are a lot of options here, and we will use only a small part of them. And for those who are interested in a more in-depth explanation about working with Parseq, I recommend to see the excellent guides, which the creator of the tool has uploaded. I will of course include them in the description of the video. What interests me in our context is only the strength figure, so I will choose only the one that will be more convenient for us to look at. Another very important figure is frames per second. This figure needs to be compatible with the frames per second of the final animation, in our case 12 FPS. After we set it up, we can upload our audio file. Then just continue according to the steps. First, estimate BPM. This figure should also be set before we generate the keyframes. Now just click on Event Detection, and you can see the red dots, which show us where the algorithm found an event. You can click on play and listen if it sounds in sync with the sound. The next step, click on Keyframes Generation. And you can see the keyframes created with the pink mark. If we look at the top of the page, we can see the keyframes on the graph, and also here in the so-called grid. According to the graph, you can see that even though we created keyframes on the beat, all the other frames still have the same value, in our case 0.6. And here we will have to work with a formula that will allow us to create a difference between the values of the keyframe and the other frames. I won't go into the math, but you can find lots of examples, formulas and syntax of the tool on this page, and of course I'll leave a link to it in the description. I use this condition, if frame is equal to a certain value, in the info column. In this case I simply copy the name of the created event, then its value is equal to 1.5. If not, then the value of the strength in these frames will be equal to 0. As you can see, I made a mistake, and this is what is convenient in the display of the graph. It is very clear what you get, so after I corrected the mistake, you can see that every time we are on the beat the strength value jumps to 1.5. And that's exactly what we wanted. Parseq is adjusted to Automatic 1111, and for Comfy we need to choose raw schedules, look for the strength from the list, and simply copy the keyframes we created. So back to Comfy, I copy the ControlNet, this time I choose a QR code. Before we move forward with the keyframes, let's first see what the result we get is. I will use the image we have already uploaded, reset the ControlNet, connect everything, and press Q. You can see that the second ControlNet definitely has an effect. Now we will connect the keyframes we created to the ControlNet. If we look at Kosinkadink's repo, this is the node we need. So we will go to the Phys Nodes menu, and select Batch Value Schedule, to which we will simply paste the list of keyframes, connect it via latent keyframes from list to ControlNet, and click on Q. And as you can see, we get a jitter that matches the bits of the sound. Of course the result is very different from what we got at the beginning, and that's because our conditioning is very strong. So now that everything works, you can do fine-tuning to reach the desired result. In order to leave the jitter mainly on the letters, we can use a mask. Of course you can draw it manually, but you can also use the image that the AIO preprocessor created for us. Let's start by turning the image into a mask. I connect the mask to the Grow mask with blur, and we connect it to the Preview mask, and we'll see what we get. Let's enlarge the mask a bit, maybe blur it a bit, connect to ControlNet and Q. As you can see now, it seems that we cancelled the QR code, but it is probably related to the very narrow mask we created and the inversion of the black and white in the image of the text. We will try to invert the image with the text before it is sent to ControlNet with the QR code. Now that we have a mask on a relatively narrow area, I will also increase the strength, and I also play a little with the strat and the end preset, and this is the result. Now that everything is working, you can run the final animation, with the required amount of frames, and get full synchronization between the sound and the visuals. So I hope you learned, and that we will meet in the next lessons. Of course you are welcome to subscribe to the channel, ask questions and like if you liked. And most importantly, have fun! Bye.